On to today's session called Smarter Solutions from Tersus GNSS, presented by Jacob Wittenberg and my colleague Dustin Harr. Today's agenda is going to include a quick introduction to Desert Creative Group and Tersus GNSS. Then we'll be diving into Tersus Smart Receivers and the newest software. From there, we'll look at visual positioning and how it will change the way you look at surveying. Then we'll be diving into planning for accuracy with real-time corrections and PPK solutions. And lastly, we'll close with a Q&A session. So a quick introduction to Desert Creative Group. We are the master distributor, or the Tersus master distributor in the United States and Canada. We bridge a gap between distribution, sales, and supporting their cutting-edge GNSS and technology and positioning solutions, and providing geospatial strategy and consultative GIS services to ensure your success along the way. Our team has over 100 years of combined expertise with supporting customers with field data collection, spatial data management, and analytics. We support you by training, consulting, and helping you solve complex challenges with spatial data and simplifying workflows. Tersus GNSS provides high-performance, cost-effective positioning solutions for industry that relies on precision. By combining advanced GNSS technology with accessible pricing, they help customers achieve centimeter-level accuracy without the traditional barriers. Tersus has a large global ecosystem of trusted partners and geospatial innovators driving success worldwide. Agile, user-driven solutions, proven in the field, shaped by real-world user feedback.
Thanks, Jake. Well, our focus is on the Tersus GNSS Smart Receivers. It's important to see the full scope of capabilities that they offer. With a full geospatial portfolio, it allows us to support a wide range of industries. Let's first start off by talking about the Nuwa software. Our Nuwa field software is our powerful, intuitive, feature-packed software that's very easy to learn. It does streamline some operations. Based on an Android operating system, this allows you to run base stations, rovers, do static observations. We have a full suite of offerings inside, including some CAD-based workflows, road, earthwork, visual stakeout and positioning, COGO features, and many more. I'll give you a little look at that here in a minute. One of the things that separates us in regards to workflow is our tap and go NFC connection. So between a controller and a GPS receiver, we can simply tap the controller to the receiver and it has it force an immediate Bluetooth connection between them. So if you see here, simply tapping the controller to the receiver, you get an audible tone and you get shown on the screen what's happening. We'll dive a little bit more into the software here for a minute. We do have a little bit longer video that goes in depth on the Nuwa software on our YouTube channel, so feel free to check that out for a little bit more detail. But quickly, I wanted to show you how our software is laid out. This software can be run on a TC40 controller, which is our larger tablet style, or the TC80, which gives you a keypad on there. You can also run this software on your own personal Android device. So starting at the main screen, you'll see that we have 4 icons across the bottom, which I call tabs: project, device, survey, and tools. In the project tab, you'll see this is where we're going to set up our jobs, our projects. We can specify our code list we want to work with, importing, exporting. All of your standard formats should be available through this screen for getting things up and going or sending data out when you're done. In the device tab, This is where we specify what we're connecting to and what we're doing for the day. Base station stuff, rover stuff, any of the settings, those types of things are all specified there. Now our survey tab, this is our most commonly used for all of our field operations. I'll first start off by clicking on the survey icon in the upper left. When we go into this screen, you'll see all across the top we have our satellites, our positional accuracy telling us our if we have tilt on or off. On the right side of the screen, we can click and specify then what kind of background map we want, or if we don't want one, we can simply turn it off there. Below that, you'll see we have the ability to immediately do some line work in the field without needing any sort of control code or anything like that, making it very easy to get going and a shorter learning curve on line work, which can sometimes be a little bit of a hurdle. Below that, we have our measuring button, and then also the gridded area along the bottom of the screen is always going to give us the information we want, whether it's an elevation or an RMS or something like that. Notice some of the other things in our survey tab revolving around stakeout, working with surfaces, roads, CAD files. If I go into CAD files, you notice we can load up a DXF map, and this is now interactive for us. So we can select lines, points, whatever we want, and work with those. Looking at our last tab, this is where we would see a lot of our COCO-based tools, calculation, some area division, any of those types of things are all in our tools tab. So that's just intended to give you a little bit of an overview of what the Nuwa software looks like. The next thing I want to show you is what we called I'll call the AR stakeout. So when you first start off and you're going to select something to stake out to, you'll notice your information on the screen. Depending on your background map and some settings, you're going to have some pretty standard information for staking things out. On the left side of the screen, if I click that little AR button, this will change my display I see on the screen of the controller. Essentially, it gives a digital arrow overlay over your real-time image, helping you stake out more efficiently. Now we'll jump into the GNSS receivers. Tersus develops our own GNSS boards and solutions from scratch, following their core philosophy of build better or don't build it at all. Starting off with the Luca. The Luca is our palm-sized, lightweight, and rugged GNSS receiver. Features the Extreme RTK engine, which allows you for all available constellation tracking. That's going to make it to where working in more challenging environments, it's going to perform better, and even giving you some faster initializations, just overall giving you the ability to use GNSS in more conditions. It has an integrated IMU, which means that you can take measurements unleveled and or hard to reach areas like you see on the right. Maybe that's not your traditional shot you're taking, but it works great for that. So this is an IMU, so it's immune to any sort of magnetic disturbances, not needing to do any calibrations or have any limitations on how far you can tilt it. It has a 19-hour internal battery, which is recharged using USB-C, built-in 2-watt radio for receiving or transmitting base or rover mode. And you saw in that quick video, this does have the tap and go with the NFC connections. And it also has a 4G cellular connectivity option. The next one is a Tersus Oscar. And the Oscar, like the Luca, has extreme RTK, tracking all available constellations, the built-in radio. One unique feature to this one is it has a control panel on the front, as you can see. This allows you to change some settings, maybe start some measurement features or capabilities that you want, change the radio channel, whatever it might be. A lot of these settings are accessible on the front display without having to need to get your controller out. This one also has the IMU, which is immune to magnetic disturbances and not needing a calibration. This one features an 8-hour battery that is hot swappable. So giving you a little bit more flexibility there. This one does have the NFC connection, 4G cellular connectivity. In a minute, Jake's going to tell you about what TAP is. So this one supports TAP, which is a satellite-based PPP solution. I'm excited to hear about this in a few minutes. The last thing I'll mention about this receiver is going to give us some of the best performance in more challenging areas, just in how this one is built and the technology that's in it. So this topic here, visual positioning, this is one of our, seems like a very hot topic of people wanting to know more about this. So I'm going to give you a little bit of a look at how visual positioning works. So this receiver, the Tersus Oscar Trek, is unique that it has a camera in the side of it. That allows for capturing imagery while we're in the field. Essentially, this is being processed in real time on the tablet or controller you're using to extract out positions and coordinates in near real time. No post-processing needed, and giving you 2 to 4 centimeter accuracy. Sometimes this is just really nice for that hard to get point or painting a picture of what it's like in the field for people in the office. So how does this work? Well, I'll give you a little bit of an idea of what this workflow is. So in the field, you go into the visual positioning routine and you hit start vision. You simply start walking along. As you're walking along here, you're focusing on your screen of your controller just to make sure that the camera is covering what you want or an area that you're going to be extracting measurements from. Maybe if you want to aim it up a little bit for a higher building, or aiming it down at the ground, maybe if you have a trench or some groundwork that you know that you're going to want to be focusing on getting more information. At the end of this walk, you hit stop, and what it does is it's going to store all of the photos in a folder. So while we're still in the field, we have the ability to look at the different groups of photos. So this last walk that I just did had 43 images. So now, still being in the field, I have the ability to do 4 different ways we can extract data out of those photos: quick survey, sparse point cloud, advanced survey, and dense point cloud. So the advanced survey and dense point cloud is a newer feature. First thing I'm going to show you is how we do a quick survey. So quick survey, simply go into the group of photos that we're working in and select that. Pick any one of the photos that we want out of this group where we know that that position is at. Tap on the screen in the area where you want to measure, and it will zoom in, giving you a magnified view to make sure you can click more precisely. Simply hit measure on the screen. You see the residuals in the upper left, and you're done. If you want to store that in your job, you're ready to go. The next thing I want to give you a quick peek at is creating a dense point cloud. Similar deal, go in to the group of photos, select the area you want to work, and on the right side of the screen, once you've selected a photo, there's this lasso icon. You're going to draw a circle on the screen, giving it an area of where you want the software to extract out that data. In this example, it's probably 1.5 minutes to extract out a point cloud. It gives you a grayed out view on the screen, indicating, hey, we've built a 3D point cloud here. So in the back, on the left side of the screen, that's actually a wall that's maybe 40 or 50 feet back. It got some data back there, some of this here. And if you want a larger area, you simply would just draw a larger circle or pan through the photos a little deeper down the list, and you can create more point cloud information. The next one I want to show you quickly is to do an advanced survey point. Advanced survey points are going to have a workflow very similar to the first one I showed you. But what this is doing is it's more accurate, because now if you have a point cloud and the photogrammetry, it's using both of those, all of that information to create a higher accurate point. Select where you want. You can select as many positions on this single photo as you want, and you can review the information on the left side of the screen, making sure it's what you want. If that is what you want to store that in your job, you hit store, give it a code and a number, and hit OK. And that is now all stored in your job. Pausing for a second here, the data that we captured on our controller and extracted, point clouds, any of that stuff, we can simply drag that into your favorite processing software. In this scenario, I wanted to look at what the point clouds look like. So this is just intended to give you an idea, what do point clouds that are from the Oscar Trek receiver look like in a 3D environment? As you can see, it's pretty good. We typically tell people to keep within 50 feet for optimal performance. Up next, we're going to have Jake talk about planning for accuracy with real-time corrections and PPK.
Sure. Thanks, Dustin. And so, yeah, planning for accuracy and looking at real-time corrections for PPK. So how do we overcome some of the challenges with high accuracy positioning in the field? So whether that's working in remote environments without real-time infrastructure access, or working with a mixed fleet of devices. Maybe we're working with something that requires a radio. Maybe we're working with something that requires in-trip. Maybe we have a solution that, we don't have any infrastructure. So we don't even have real-time corrections. Maybe there's no cellular data or connectivity available. We're working across the country or globally. So the challenges of finding correction sources might be a challenge. Also, variances in real-time reference frames. So if we start looking at that and looking at how do we solve some of those solutions, Tersus offers flexible solutions to help you get the job done more efficiently. So both the Luca and the Oscar Ultimate as well as the Oscar Trek, both support rover mode. So we can capture points, lines, polygons, and we can capture that with the newest software and store that information. But these receivers are capable of a lot more. They can also be set up as a base station and broadcast in-trip corrections using their in-trip caster software, the Geocaster. This allows you to push RTCM 3.2, 3.1, even CMR protocols to multiple users over the internet. You can also log static data. So if you want to log static data to post-process with, either receiver can be set up to do that. They also both have a built-in 410 to 470 megahertz radio. So you can broadcast again, RTCM 3.2 or CMR protocols for mixed fleet solutions. And lastly, they also all support TAP. So for real-time, basically TAP is a real-time subscription-based correction service. And we'll dive into that here in a little bit. But first, I want to talk about the Tersus Geocaster. So this is available to all users with a Tersus Smart Receiver, such as the Oscar or the Luca. It includes the ability to configure your receiver as a base station and easily broadcast real-time corrections to a rover. Think about it for machine control, maybe an RTK-capable drone, but anything that can get in-trip corrections, you can broadcast to from your Luca or your Oscar receiver. They have a hosted cloud service that allows for this to easily push corrections from your receiver to their cloud-based Geocaster software and allow for a multitude of different applications to receive the corrections. Again, RTCM and CMR protocols are supported. If you need something more permanently set up than your smart receiver, Tersus also has the GeoB solution, which consists of their David 30 GNSS receiver and an in-trip modem. So the benefit of this is the modem broadcasts corrections through the internet via Wi-Fi. Also has a SIM card slot, so you could pop in a SIM card and have 3G and 4G connectivity. You can connect to it via Ethernet. This helps with redundancy and stability in the event one of your communication networks goes down. So we've had customers actually want to connect up things such as Starlink for remote applications, which can all be done through the Ethernet port or through Wi-Fi. So similar to the Geocaster software, with the smart receivers, users can easily set up a permanent base without the supporting infrastructure required, such as a server and a static IP, because it's all cloud-based. 20 users can access this cloud-based solution at once. So if we look at the management of this solution, there's an admin panel for configuring the users. So you can configure things such as usernames, passwords, set the expiry date for users. So if you want to set a limit on that, or even set the limit of the number of days that a user can access the corrections through the Geocaster. You can actually set that, and then you can also set how many people can log into a specific account at once using the same credentials. This is a great option if you're working in the same general area with a stable access to the internet in the field and need corrections day in, day out. But let's say that you're working in an environment that doesn't have stable connection to the internet. Well, that's where Tersus's advanced positioning TAP service comes in. So if you're looking to work in more remote areas or across a wider footprint, like say across the country on different projects, their PPP, which stands for precise point positioning solution, is different than a traditional RTK correction, as it does not require you to set up a base. Actually, it's a system developed by Tersus to provide real-time corrections via L-band geostationary satellites, which can achieve 1.5 centimeter of horizontal accuracy very quickly. Convergence times to achieve that is generally less than 3 minutes. Again, this is a global system, and in most cases globally, you'll have at least 2 L-band satellites broadcasting corrections at once. This is a subscription-based model, which allows you to easily achieve high accuracy without the headaches of setting up a base station. So next I want to talk about, a traditional workflow, right? So if we look at a GNSS workflow priorities of a professional drone user, they may need to be able to use this receiver for capturing ground control points. They may need to be able to, set a base coordinate for initialization, whether that's capturing that and creating an NGS solution, or maybe they want to set that base up and or set up and capture a position for a base coordinate using the PPP solution. Maybe they need to use in-trip corrections for a drone. Maybe they need to post-process their data after they've flown it. Maybe they need mixed fleet compatibility because maybe they have different types of drones. Maybe after their project's completed, they want to go out and they want to do accuracy validation of the work that they've done. So they want to take this out and stake out some points or do some checkpoints in validation. One of the nice things is that these receivers are adaptable to really any field task. You can capture data as a rover. You can broadcast real-time corrections. You can log static data that have flexibility built in so that if you're working in the field and you don't have access to the internet, but you have 2 receivers, you could set up as a base rover combination via the radios. Or if you just have a rover only, you could use their TAP-based PPP subscription service and allow for high accuracy in the field. So as we close, I want to highlight again the adaptability and the multifunction ability of these solutions, because they allow you to really be more efficient and more productive in the field, allowing you to accomplish more with less. So with that, I want to open to questions.
All right. So looking at a couple of the questions we have here, we have a few minutes left, so we'll go through some of these. One of the first questions we have is originating around the stated accuracies from the 2 to 4 centimeters around visual positioning. So absolutely, those specifications are based off of your core position that you have happening from your GNSS solution. So if you're using a network solution or a base, or how far away along your baselines are, your positioning accuracy that you have in the field, along with how far away the object or subject that you're measuring is kind of where you're going to get that range. So hopefully that helps a little bit there. We have one more question around how much do the receivers cost? Well, without getting too close to get into the details too much, any of the receivers highlighted here are in between $8,000 to $12,000. I have a question around the Nuwa software. Can I run the Nuwa software on my Android phone? Yes, you can run that. It's a free app download from the Tersus website, and doesn't have any fees to use it or annually or anything like that. The warranty on the receivers, these have a 2-year warranty. Let's see. Can I load a surface or DEM into Nuwa and get a cut fill? Yep, actually you can. That's under the survey tab. You can load your file in there, stake out to a surface. It'll read a cut and fill from that file. Let's see, one more here around. So is there a subscription fee to the Geocaster software? So the Geocaster software, that is actually included with your purchase on your equipment, and Tersus is actually hosting that cloud-based service for you for up to 20 simultaneous rovers using the Geocaster software. Just look and see if I have any other ones here quickly for you. So question around the Office software. Again, from the Tersus website, you'll see that they have a couple different software solutions. They're going to be used for more of your core processing, so maybe some post-processing, some QA, QC, and that's called Tersus Geomatics Office. And you'll see that they have a Tersus Geomatics Office 2 that is in its earlier stages. It's there, but I would say it might be a few more months before you see the full support of what the goal of is, and that's supposed to be able to host all of your data from GNSS to LiDAR, point clouds, any of that type of stuff, because we have some different SLAM and aerial LiDAR solutions, and that'll all run through that. Yes, there will be a recording of this webinar available. You should get a notification once this webinar is complete, and you'll be able to see a recording. And we have a YouTube page, which is Desert Creative-Tersus, and at some point we will load that onto the YouTube page as well. Are there different modules that need to be purchased, or is roads included? The roading capabilities are all built into Nuwa, and that's not an additional module or anything that's needed. With that, I think I see all the questions that I saw through here are answered. If we look through these questions, I do see a few more actually coming in too. If we look through these, we'll try to get these answers out as a follow-up and get these to you. There's another one. What is the dense point cloud format? Yes, it's automatically colorized as it pulls out. The tilt sensor is an easy on and off. Absolutely, it's just a toggle. Basically, you want the tilt on or off. So I still see more questions coming in, but just to be cognizant of time, we will answer the rest of these either directly with people or as a follow-up email. So thanks again for your attendance, and talk soon.